they make these links very intrinsically. Land degradation then is of course caused by a complex interaction of many social, economic and biophysical aspects, and that makes it all too complex. What the other reports also said is that climate, biodiversity, land degradation cannot be tackled in isolation. And I think that's one of the main messages of all these publications coming out. So we have all this data, and many data, and I said I could stand here 2 hours and go through them. So we have data on population, on economical aspects, agriculture, the use of the land, export and import of water and products, meaning that we impact remotely through our consumption, soil carbon, plants, expansion of agriculture, food crops. So there are many data sets, and what can we do with these? How do we bring that all together? Baron mentioned indicators, yes, but we all know as well that land degradation is too complex to be represented by one indicator. We can build, if you want, proxies towards it, but we can never represent it by one indicator, simply enough because we cannot model all these interactions of all these aspects of which you see all these data sets scrolling through here. We cannot model that because they interact differently because of different socioeconomic situations, because of different biophysical situations, and even if they would be the same, they would interact the same, the impact would still be different because they still have impact on very different local socioeconomic biophysical situations. And my scrolling takes a little bit longer than expected, but we're getting through it. These are mine sites, for instance. So we have a lot of knowledge on the data, and we have a lot of data available of many issues that are important to land degradation, that are related to land degradation, but of course none of them, which we call global change issues, on their own fully explains land degradation. So we have to combine them. And as I said, we cannot model that because we don't know their interaction. Locally maybe we do, but generalized over the globe we cannot, because they impact, as I said, in different ways. So we start with many observations. We deduct some conclusions, and that's a way of abductive reasoning. Okay, so there, our approach was convergence of evidence, which is of course not a new approach, but is a simple, non-assumptive approach, let's say, to deal with lots of data, lots of different data, and get something useful out of it. So we have this collection of multiple independent sources of evidence. When viewed collectively, and I don't know if you looked through the scrolling of my maps, some of you might have seen patterns popping up, things which are always in the same place. So when you view them collectively, some of these point towards something. So you can take a conclusion, and of course we take conclusions here in relation to land degradation. Convergence of evidence, these analyses are suggestive. They are not diagnostic, because you don't follow any particular methodology to come to your conclusion, let's say. But what is, I did something wrong here. But what is very important is that these conclusions can be very strong, even if, as we know, the individual items, individual sources by themselves are not strong enough to point to that. Setting up this convergence of evidence, as I said, follows an abductive reasoning approach. That means conclusions which you have taken can be improved in a recursive manner when better data, more detailed information becomes available and knowledge increases. So it's a living kind of approach, if you want, which adapts and can adapt the conclusions you take from it. The best example at the moment of the use, let's say, of convergence of evidence approaches is the climate change conclusion. We know that data on pollen records, tree rings, ice cores, glacial ice cap melt, sea level rise, temperatures, CO2, etc. Maybe one of them doesn't really point in one place at global climate change, but if you put them all together, they do. And that's a convergence of evidence as well. So for the atlas, as an example, we took out of these many data sets we have, we took 14 which relate quite good to land degradation, and also because we had the data and information available on change at the detailed level at 1 kilometer at global scale. So they were good data sets. There are others, and as I will say, the exercise is illustrative and can be done also with other data sets. So we have data on population, income, build-up areas, agriculture, irrigation, water stress, climate vegetation trends, that means the effect of droughts, for instance, fires, tree loss, and so on. So how did we do that? Very, very simple. We have a stratification of the world in, say, 3 classes. It's a little bit more than that, but cropland, rangeland, and forests. Then for every of these classes, and now we did it global because it's a global atlas, from the data sets we calculate the distribution, we set a threshold. Above the threshold, you get the issue considered as important as an issue, below not. And then you make the sum of the layers, and you have a per pixel value which indicates the coincidence of global change processes at that particular moment on that particular place. And this is the result of that. So you have here the colors from blue to red, 0 to 13. I said we have 14 issues. One is mutually exclusive, so you can only have 13 maximum. And you see immediately on the globe where pressures occur. Now, there is no one-to-one relation, of course. If you have more pressures, that this is more of a problem, because you can, of course, deal with them. And that's what I said. These conclusions you take are suggestive. They are not diagnostic. But, of course, you take a conclusion with knowledge, and you take a conclusion with local knowledge. But, But of course, we can already also at global scale take a number of conclusions, and we can extract quite some nice information. And I just show you very, very short and quickly here. These are, for instance, number on the x-axis, the number of coinciding global change issues. You see the world has an average, if you want, 3.6. And then you see the difference between the drylands and the non-drylands very clearly already. The drylands have remarkably more contemporaneous issues than the non-drylands. If you look per continent, you see Africa, Asia, South America just at the global average. So you can make a number of conclusions at global scale. You can map the most popular, if you want, combinations and where these occur. But of course, as I said, for making conclusions, you need your knowledge as well. So stakeholders have their particular focus. And we try to illustrate that in the atlas by mapping the same kind of data with different masks. Here you see the same map with everything which is colored on the map is high density cropland. And you see the convergence of issues in high density cropland. Now that means that you get a whole number of different statistics, which means you can compare continents again, but specifically for that land use. So that's very important. And for instance, a conclusion here could be that 14% of the high-density cropland on the globe, the multiple global change issues negatively impact on the land productivity. And that's by the data. We can do this by land use. You see the graph here of increasing coinciding global change issues. And at the bottom there we are in smallholder areas, irrigated areas, high-density agricultural areas which have systematically more issues. And I said, of course, for monitoring and decision-making, you need local contexts. So it means we have to have a living data system, and we need tools also to do so. So it is living. So we are developing the tools. I invite you to look at the website, which is improving constantly. You can interrogate per country, and you see, for instance, the distribution in kilometers, and you can map it, and if you click on one of them, you can map it for the country. You see which biophysical global change issues are currently of importance, for instance, in India, which socioeconomical issues are important, and you can map them. And then actually you can interrogate the map on the pixel level. So you zoom in, you see the pixel, you say this is a 1 kilometer area, which global change processes are ongoing at that particular place, which means you can make conclusions out of that. Okay. So the approach basically, as I said, in the Atlas we rather decided to not map land degradation as such because it's very perceptive, it's very debatable if you say this hectare here is degraded or not. And of course locally I said you can do that, at global scale we couldn't. But we thought, okay, if you look at what are the problems on the area, you mean if you know the problems, you're solution oriented. And you can provide and define your solutions, for instance, trade-off planning, adaptive management, etc. And this is fully conformed to the LDN approach of the UNCCD. Now we are, one second more, we are making the convergence of evidence into a tool so that everybody can actually, and okay, it will still take a little while, can input their own data, as we did for the Atlas, but you can do it at regional level, at national level. You go through the exercise, you come up with a map, as I have it there for the globe, and based on that, at whatever scale, for whatever focus, you can make focused solutions. And my time is up. Thank you very much. One more line. You can, I've noticed that the Atlas, the copies are finished at the UNCCD booth, but you can actually, if you look on the website as well, you can, first of all, you can download the whole file as it looks in the Atlas. Then you have the website, you can look through it more interactively, you can interrogate the maps, and you can order, and it's indicated as well, a hard copy at the publication office of the Commission in Luxembourg, and they will send it to you. Thank you very much.
Jeff, if you're still here, come back up on the stage. So, you now have a sense of how we can take multiple data sets, bring them together, convergence of evidence point us towards a solution. But it's still a major problem. And what's really powerful about what IPBES did in their last 2 assessments is they took on some of the elephants in the room. They took on challenges like unsustainable consumption and how one country can influence land in another country, and a wide variety of other issues that led to the conclusion that 1 million species are at risk. And one of the coordinators of that entire global assessment, which by the way was the most newsworthy environmental assessment in history, it was extraordinary the impact of it. Maybe the IPCC climate change and land will catch up, I don't know, but it's probably a trend that's going to be happening more and more. But to introduce that, we have Joseph Settle, the coordinator for, one of the co-coordinators of the IPBES Global Assessment.